This video is going to introduce you to the establishment of estimation models using linear regression based on catalog data. During sizing and optimization process, different types of model will be necessary. Estimation models. They permit to estimate from a reduced set of main parameters all the parameters necessary for simulation, for integration study, masses, dimensions, and for the validation of the component's smooth running. They substitute the use of catalogs when these are not available or when we want to explore design domains, such as scenario analysis or optimization. Simulation models, they give the possibility to compute power variables, powers, energies, and all other sizing quantities for each architecture's component. Evaluation models, they help to verify that each component will remain within its working limits and will last at least the lifetime required. We're going to study the establishment of these models thanks to catalog data. During preliminary design, and especially solutions optimization, it's interesting to have simple equations in order to compute the component's main characteristics. We're now going to see how to transform data into algebraic equations using regression. Examples of this course will be given using gear reducers. The main steps to follow in order to obtain an estimation model using data are 1. Obtaining data. Components data can be provided by catalogs or design models on which we will have simulated a set of well-chosen design parameters using design of experiments, for instance. 2. Choosing parameters representing primary characteristics. The objective here is to reduce the number of inputs for the model. In order to do that, we can detect and choose the most important parameters using a correlation analysis. A dimensional analysis can also help to reduce the number of coefficients to be considered. 3. Choosing the mathematical model type. This means choosing the mathematical form of the equation on which the regression will be applied, which is polynomials, linear sum of functions, power products, etc. And 4. Apply the regression. The objective is to minimize the disparity between data and mathematical equation of the model. The objective here is to give ourselves the mathematical tools usually used to characterize a data series and the links that exist between two data series, here x1 and x2. The mean of each data series, the standard deviation, which gives the dispersion of a series of values around their mean value, the covariance, which is a number that gives the possibility to evaluate the variation of two-way variables and, that way, define if these variables are independent or not. That way, if two quantities vary the same way, or in the opposite way, the covariance value will be higher. And the correlation, also related to the link between two variables. It's actually the covariance normalized on the scale from -1 to 1. In our example concerning the gear reducers, we want to determine which parameters are the most important for an estimated mass. Using catalogs data, we can apply a correlation analysis and display it as an array, which represents the correlation between each parameters. This array is symmetrical. We can notice that the reduction ratio and number of stages has small influence on mass. The most important parameter is the output torque. Therefore, we will use the output torque as an input variable for our linear regression. The linear regression indicates an approach to model the relation between a response parameter y and a vector of independent parameters x1, x2, etc. The term linear comes from the linear effect of the coefficients a, b, c. The choice of the functions 1, x, x squared is not unique and could take other forms. Linear regression is simple if the independent parameter is unique, such as x. The coefficients a, b, c contained in the vector beta are determined in order to minimize the overall error between the estimation and the data. Here are a few examples of simple linear regression. One input on mass and inertia for a set of reducers, Sumitomo. For inertia, two types of models have been used, an order 2 polynomial and a power. In order to validate the exactitude of a regression, several methods and quantities can be used. First, the determination coefficient r squared, which translates the percentage of variation given by the regression function. R squared is a value between 0 and 1. The more correct is the regression, the closer it is to 1. Or a graph, representing the estimation and the measurement of a quantity. The closer points are to the curve y equals x, the more correct is the regression.